Hello, everyone. Thanks for joining the session here today. My name is Darren Evans. I'm the hardware commercial leader for Bentley, Nevada. We're here today to talk about the Orbit 60 platform. This is Bentley, Nevada's next generation protection, condition monitoring, and data integration platform. Before I dive into Orbit 60, I do want to take a step back and talk about Bentley, Nevada. So many of you joining the call today are very familiar with Bentley, Nevada. We've been installing equipment at facilities globally for over 60 years. Many of you are also familiar with our headquarters location in Minden, Nevada, whether you've came out here for training or factory acceptance testing. So all our products are manufactured and shipped out of this facility. 3500 is a good example, and Orbit 60 will follow suit. So as we talk through the architecture and the features of this platform, it will be made and manufactured here in Minden, Nevada, and shipped out to our customers globally. This headquarters building here also locates our engineering team, our product support team, tech support team, and all their functions to support the different aspects of the business. So hopefully in the future, we'll have an opportunity to host you at our facility, whether it's factory acceptance testing or on-site training into the future. So before we dive into the Orbit 60 architecture in more detail, I just did want to take a quick overview of the Bentley Nevada product portfolio. Over the last 15 years, the Bentley product portfolio has changed quite a bit. We traditionally were known for more distributed rack-based systems. So for example, 7200, 3300, 3500, we're very focused on API turbo machinery applications. Over the last 15 years, we've developed a pretty broad product portfolio for different applications and different types of machines. So, for example, the VB Online Pro was very much targeted for the wind industry at the beginning. So, roller element bearing machines, complex gearboxes. And the Trendmaster is an intrinsically safe offering that you can install in your oil and gas facility and do more of a daisy chain sensor configuration. The 2320 is a smaller 2-channel monitoring system designed specifically for smaller applications and machines. And the 3701 is much more of a distributed architecture to be skid mounted by the machines. 3500 everybody knows very well. There's over 85,000 of them installed throughout the world. And that is absolutely our flagship product as we talk here today. And then we're going to focus on the Orbit 60 platform, which the vision of the platform is to take in all these different hardware products that we have and bring it under one architecture, meaning Orbit 60 will have the features and functionality to be applied to all the different applications that you see here. This is not to say that we're going to discontinue any of the products that you see here. Many of these products are very new, very modern. Orbit 60 is going to offer a new option to bring in all the different capabilities to a single architecture here moving forward. All our products tie into a System 1 visualization layer. So System 1 Evolution, and that's where you do your visualization of all the vibration data coming in. You can also do diagnostic HMI. You can do rules. You can do analytics. You can do exporting of data to third-party systems as well. And then at the very bottom, our services team kind of pieces this all together. So we are involved with installation, configuration, commissioning of these systems, but we also have ongoing support for our customers, whether it's hosting data in a cloud environment or doing alarm and event management for customers, analyzing the data, providing reports back, whether it's on-site training or even cybersecurity assessments. So really wing to wing from a services, software, and hardware standpoint, you can come to Bentley, Nevada for that whole offering for your particular facility. So one question that comes up typically right before I dive into Orbit 60 is, what is the support of 3500? And as I mentioned a moment ago, we have over 85,000 3500 racks throughout the world, a very large installed base in really every country in the world. So this is not an insignificant undertaking to announce a new product into the marketplace. 3500 came out in 1995. System 1 capabilities came into the platform in 2001. This product has gone through many major updates, whether it's aligning to the RoHS directives out of Europe or aligning to new applications or new circuit components that come out in the marketplace. So the 3500 that you have today, if you were to open up one of the cards and compare it to a 3500 that came out in 1995, you'll see a vast difference regarding the circuit design and the different aspects of the system. It's a very modern system today, and it will be supported well into the future. The one thing I'd always like to compare to is the 3300 and 3500. When we came out with the 3500 in 1995, we had a very large installed base of 3300 racks globally. And we listened to our customers, and we understand that it's not as easy to upgrade one of these systems as you may think. You got to align with outages, you got to get approvals, you got to get budget. We supported the 3300 system for 18 years after announcing the 3500 system in the marketplace. We're absolutely going to do the same thing when we bring the Orbit 60 into the marketplace. 3500 is going to be around for many, many years to come. So you'll have a choice either to go with 3500 on a new installation, retrofit, whatever it may be, or you'll have a choice for Orbit 60, and you'll see some of the new features and functionality that are coming into that platform here moving forward. So again, the choice is yours. If you've made a recent investment into 3500, it'll be around for many, many years to come. The product is still in P1, which in Bentley, Nevada terms is we're still adding new features and functionality to 3500 right now as well. So you will be announcing those very soon as well. Okay, let's dive into the timeline of Orbit 60. So right now we're ATQ. That's available to quote. We came out in ATQ in April of this year. So right now we're doing fixed price proposals, either for new facilities, retrofits, and we're also approaching alpha beta testing. So we have a large quantity of customers globally where we're testing out this either in test benches or on machines out in the field. We're currently getting certifications and approvals of the product. As many know, that's quite a process in and of itself to get these regulatory companies to do the certifications on the product. So those are all activities happening as we speak. ATS is available to ship, and we are going to hit ATS in April 30th of next year. And that's going to be for a full-featured product for plant-wide and API turbo machinery applications. So if you have a compressor aligning with API, you'll have all the necessary monitoring parameters in Orbit 60 at that particular time to deploy with all the necessary certifications. August 31st of next year is when we're expanding. This is still considered release 1, just in 2 drops. Expanded TSI functionality focused on turbo machinery, steam turbine turbo machinery specifically, and Ethernet and fiber optic bridging capabilities. So that's where you want to connect multiple of these Orbit 60 systems together. That'll be coming out in August of next year. And we'll talk about more of those features here just shortly. So that's just a quick overview of the timeline and events here with Orbit 60. Okay, let's dive into the benefits of Orbit 60. As I mentioned before, 3500 is our flagship product. I'm going to use 3500 as a comparison purpose as I talk through this, as most are familiar with that in the architecture, how you deploy it, how you'd engineer it, and configure it. So Orbit 60 is our next generation platform, and it's really designed for and optimized for plant-wide. So we're not saying that Orbit 60 is only going to be focused on turbo machinery or reciprocating compressors or field-mounted pumps. We're going to accommodate all those variations of machines with one platform here moving forward. So really, Orbit 60 is positioned for the future. If you think of 3500 and the longevity of that product, we're easily going to be able to commit to 30 plus years of product support on the Orbit 60 platform. Orbit 60 has 100 times the processing power of the industry standard, which is 3500 today. So what that allows us to do is a lot of new applications. So what you'll see is Orbit 60 aligning to things that Bentley, Nevada perhaps didn't have focus on before, and you'll start seeing many of those new applications come out in alignment with Orbit 60. It's designed for the future, whereas technology has been improved vastly over the years. Rather than jumper settings or hardware changes, we've designed Orbit 60 to really align with firmware upgrades as we look well into the future. So we're not expecting significant hardware change of this platform after release 1. We're expecting most of the features and capabilities are all going to be made available via firmware updates. So back to plant-wide monitoring. As I showed in the previous slides, we have that broad product portfolio. Maybe you put a 2300 on a pump that's remote in the field. Maybe you'll apply a VB Online Pro to your fin fans or cooling tower fans that have roller element bearings. Then you would have 3500s back on your turbo machinery assets. So Orbit 60 is really designed for all these different applications. It can do best-in-class sleeve bearing monitoring and also roller element bearing analysis. 3500 had some limitations when it came to roller element bearing machines, so lines of resolution at 800 lines, whereas Orbit 60 is going to come out of the box with 3200 lines, and it'll be expandable into the future. And this is really a common scalable hardware platform for the entire plant. So instead of having multiple different systems that you'd have to support and maintain and upgrade either firmware or do training on, you'll have one system here that can really accommodate everything, and one system that your whole team needs to learn. The Orbit 60 platform is absolutely scalable as well. So 3500 had, it was fixed to the size of the chassis and how many points you can put into it. Could it be anywhere from 54 and up, depending on the combination of vibration cards and temperature cards that you may have had. Where Orbit 60's architecture supports up to 80 dynamic signals. So we're able to bring in many more signals into this platform. And that's really due to the architecture and the processing power enhancements that we've been able to do with this platform. What that allows you to do is look at larger machine trains, maybe in some cases reduce the quantity of 3500 racks on a machine. There's many cases out there where we have multiple 3500 racks installed on one asset. Or even more importantly, that I'll also talk about in a few minutes, is more of the scalability of the system and how you can distribute the system throughout your facility and tie it in through bridging type concepts. And again, as I mentioned before, the common support, reduction of spares. We've reduced the quantity of modules in the Orbit 60 rack from 3500 by 80%. We have one PAV input module, which can take in a prox, Excel, or velocity reading. That we see as the 90% use case for all the applications we have globally. So again, you're going to have a much smaller spare part stock room for this particular product than the previous ones. The one key difference in the Orbit 60 architecture is how we communicate with the DCS. Traditionally, like 3500, we've always published data to the DCS. And then in the DCS, you'll either visualize that data with local HMI, or you'll take that data and move it over to an operator for trending and basic information. With Orbit 60, we can absolutely do the same thing, but we're going to utilize that same connection that we traditionally publish the data to retrieve the data. So now if it's megawatts, it's temperature readings within your DCS or control system, we can now bring that over from the DCS connection back into the Orbit 60 platform. There's many things we can do with that. One is we can take that data and bring it into System 1 to visualize it. As you can see on the screen here, this is an example of the process data HMI built into System 1. So you can not only you can look at one asset, you can look at the process around your assets by bringing that process data in from your DCS or control system. At the hardware level too, we could take in a process parameter. Let's just use megawatts, for example. Bring that in and do state-based decision at the hardware level. So we could take in megawatts and you could set different alarming set points, perhaps with different operating modes of that particular machine or operating areas of that machine. One good example is always hydro. You know, some of those hydro units, they pump water during the day up to a storage facility or at night, and then during the day they generate electricity by taking that water and flushing it back down. And so in this particular case, you could set up Orbit 60 to really focus on those two distinct operating modes. You can have operating mode 1, where all the alarm parameters are associated with the pumping side, and then alarm set number 2, which is associated with the power generation side. So it really does open up a lot of really interesting new ways to tap into your process data, because in the end of the day, when an event happens on your machine, the vibration data is critical and it absolutely gives you key insights into the machine. However, the process data fills in the void or any whatever gaps in data that you may have. So you always want to look at the vibration data correlated to the temperature data on the bearings, for example. We can visualize that and bring it all into the same platform, which is System 1. The cybersecurity aspects were the #1 focused design criteria of Orbit 60 when I went out and visited our customers on what they wanted out of the next generation system. We are aligning to IEC 62443 and specifically 4-2 up to security level 4. This not only has to do with how you actually design the system itself, but it has to do with the whole process around how you manufacture the system, how you upload firmware, how it's shipped out of your factory and it arrives to site. Does it know if anything has happened to it along the transit? Does it know that any third-party software has tried to attempt to download firmware into it or something along those lines? So it's a full wing-to-wing process around cybersecurity that Orbit 60 is focused on. But very importantly is how it connects into the System 1 environment. Right, where if you use 3500, for example, in 3500 you had one common card, the 3522, which had both your condition monitoring data and also had your protection data stored on it, or it was your gateway into those two different platforms. With Orbit 60, we physically isolated the condition monitoring and protection networks completely. There's physically no way that the protection side of the system can talk to the condition monitoring side. And it's an innovative patented circuit design that we've came up with Orbit 60. So what this means is the overall cyber risk assessment with Orbit 60 is going to be much more favorable. And it typically will see a significant reduction in how you deploy this system as far as networking components, complexity of your network architecture. The customers that we've worked with in the initial stages here, we're seeing upwards of 50% of cost savings associated with your network infrastructure with Orbit 60. Things like database replication, complex firewalls, external data diodes. Those are all things that have a much more simplistic approach when looking at tying directly into the Orbit 60 architecture. Now, the remote I/O is a very interesting and probably one of the key innovative differences between this platform and other platforms that Bentley Nevada has is when you put an Orbit 60 out there, you're not limited to that particular footprint of the Orbit 60 for your condition monitoring and protection needs. You have the ability to take a previously installed Orbit 60 system and add a bridging module to it and expand into another Orbit 60 system. And like a lot of the bridging technologies that are out there today, it's taking very specific data pieces and translating them from one system to another. For example, like a speed measurement from rack 1 may be translated to rack 2 so it can consume that. But those two systems have their own processors, they have their own relays, they have all their own key functionality. The Orbit 60 architecture was the fact that you could put all your processing, you could put all your relays in one Orbit 60 system, and then a kilometer away you could have another Orbit 60 system with just field IOs next to your machine, and you can connect those both together via Ethernet or fiber optic in the case of a kilometer away, and it acts like it's one system and one backplane. The speed of data collection and analysis is just like you'd experience today with 3500 and aligns with the standards out there in the marketplace today. So if the field IO concept is very interesting on new projects and new installations for condition monitoring protection systems. We're seeing about a 68% reduction in field wiring costs. So if you can imagine if you're running field wiring 800 feet from one location to another, and you could take one of these Orbit 60 systems, mount it right next to the machine and reduce that down to 40 feet and use just 1 or 3 fiber optic communications from those two Orbit 60s, you can imagine that the conduit, the field wiring costs, the physical labor and the materials is going to be greatly reduced in how you deploy these systems. Also, this allows a lot of technical advantages, is unlimited field wiring distance. So with many of the existing technologies out there today, there's a rough rule of thumb of about 1,000 feet from one sensor to the monitoring system. There's obviously caveats to that depending on the application and the dynamics. But with Orbit 60, by doing the fiber optic and Ethernet, we really have unlimited field wiring distance now. If you take an Orbit 60, put it next to the machine, tie them over fiber optic communications, you can run that signal now over a kilometer from the machine back to where the processing is being done. This also eliminates ground loops and noise issues. As you say, from a digital connection now, rather than the multi-triad signal cabling that's running that great distance, you really eliminate all the ground loop and noise issues that a lot of people struggle and suffer with when deploying these systems in the field. So the field I/O concept, or the remote I/O concept of Orbit 60, is a very innovative design. We're working with dozens of customers globally right now on deploying this for new global projects, and we're seeing significant cost savings associated with that on this new innovative architecture. The other thing would be at the bottom right-hand corner here is this control room RE optimization. So with Orbit 60, you've noticed that it's a smaller form factor than 3500. The picture up in the left-hand corner is roughly half the height of a 3500 rack. It's 3U versus 6U, and you're able to put many more Orbit 60 racks in the existing control panels than you would with 3500 today. Obviously, one of the biggest limiting factors is the amount of signals that can come in, but by reducing the footprint of Orbit 60, the terminal, there's more room for terminal blocks in your cabinets, and in turn, we're seeing about a 50% reduction in overall cabinet space in your control room. So obviously, there's a benefit from the reduced quantity of cabinets, but also the benefit that can be received by the folks that partner on this platform is the fact that their control room size may be reduced. Like, for example, offshore platforms, this is ideal. You can gain real estate back by partnering with this type of design. And even if you take the Orbit 60 racks and you do the field I/O configuration, as you kind of see visualized on the screen, you even get further cost, footprint savings and cost savings associated with your control room and RAE. So this was kind of a high level, several of the key features and benefits of the platform, and how it differentiates itself today versus the previous Bentley systems and frankly the competition out there in the marketplace. Okay, let's dive into some of the technical details really quick. So from a overall footprint perspective, we'll have various different sizes of the Orbit 60 available. So we'll have a 3U and a 6U height version of it. The 3U is what you see here in the bottom left-hand corner of the screen. That is, it's 19 slots of capability in that 3U position. And we'll also have a 6U version of Orbit 60, which you see in the upper right-hand corner here, which is, for lack of better words, two of these 3U bases stacked on top of each other, but you'll have an internal bridge. You won't have to have anything external to the system that will communicate to the upper and lower chassis. And that one will have 28 slots available to it. We will also have a smaller form factor, which you see in the bottom middle of the screen, which is a 10-slot base. And that's more for field I/O installations where we're going to put it out in a very small cabinet next to the machine. Or if you have an application specifically that takes up, only has a few monitoring points that won't take up very much real estate in that particular cabinet. There's more models to come. We're going to have very models of the size of that field base. Right now it's going to be 10 slots, but we'll have multiple different options of that in the future. And as you see on the right hand corner here, the 6U base is designed to fit the exact location of existing systems. So if you are upgrading from one system to another, it'll be very straightforward. It'll fit within the same volume. And also, if you're looking to gain some control room space or your cabinet space, 90% of the time you can upgrade a 3500, a 3300, or any other system out in the marketplace to a single 3U version of the Orbit 60. So you'll be able to gain about 50% of your cabinet real estate and have all the same channel counts within this particular platform. So diving in a little bit closer to the system itself, there's some key distinct differences between this platform and some other ones that you see out in the marketplace today. The first one is, regardless of how you mount the system does not change. Whereas like with 3500, if you ordered it in a bulkhead form, you would take the rear I/O modules and you'd place them above the front monitors, and inherently you would have a 12U height system. Very shallow in depth though. With Orbit 60, everything slides into the rear of the system. So we have no longer a relationship between monitor cards in the front and the IOs in the rear. And so you have common processing throughout the whole system. You have, it's more of like a distributed PLC architecture concept than it is of the traditional, you have relationship between a monitoring card and an IO card for every single slot. So regardless of how you mount it, you have either this backside is going to be mounted against a mounting panel, and you obviously wouldn't have the display in those particular cases. But you will have LEDs and all these other things that will be available if you mount it EIA or panel. These will just be hidden if you mount it against a rear panel and you use the bulkhead mount brackets. But all the visualizations and LEDs that we have on this platform can be visualized on the front and on the back. So everything we've done on the back in the system is also in the front of the system. So you have access from either side to get the benefits out of the different features. One example is the buffered outputs. So most of the systems that you've had experience with historically have BNC connectors. Those are those big round connectors on the front of the system. There's one dedicated for every single channel. And those are very dated interfaces to get the buffered output data out of one of these systems. Why you'd want to do that is typically you'd want to connect like an Aldrich 408 or another diagnostic instrument into an Orbit 60 and look at real-time information coming out of the system to do your diagnostic and analysis. Now, with Orbit 60, we have more of a modern connector, industrial connector that you see there in the upper right-hand corner that will plug into these ports on the front, and it'll give you your 4 buffered outputs as the output there. So in cases that customers want to still interact with the buffered outputs, we were able to reduce our system overall design by taking those more archaic connector styles out of the system and replacing them with a new modern interface. We are seeing the need for buffered outputs to go down significantly with our customer base. We don't see the use case of these nearly at the same level as when 3500 came out in the mid-90s. Because most of these systems are connected to an online software environment, just like System 1. The other thing you see on the front here is the configurable display. Again, this is a Release 2 item. This is not going to be available in 2021, but early 2022 is the plan. And this will have some configurability. You can set there's going to be 5 unique screens. You can set each screen to whatever the user preference would be, whether it's overall values in relation to your alarm and danger set points, alarm and event list, which you see all the way to the right, maybe a machine trained diagram, and real-time viewing of the data. This won't have any historical or data storage capabilities in this particular module or display, but you'll be able to see real-time. Really the intent of this display is an operator display. Okay, if we flip around to the back of the system, there's a couple kind of key points here in relation to like 3500 today. You'll notice that we no longer have power supplies built into the system. Much like most modern systems that are out there today, most of the power supplies are being removed, and that's going to be something that's maintained at a cabinet level and distributed to all the systems that were within that operating panel. By removing the power supplies, we actually gain some good, there's some technology gains that we can get from doing that. One is we can raise the overall operating temperature of the Orbit 60 to 70 degrees C. Or 3500, for example, was 65 C on the upper threshold. The external power supplies that we will have available will be rated to 70 as well. But just kind of keep that in mind that the only inputs into the Orbit 60 that you see here is 24 volts DC, and then you have a variation of power supplies to convert that. And again, as I mentioned earlier, this is more of a distributed architecture. So you have like a common processing module that looks at all the inputs coming in, does the processing at one single location, and it takes those process parameters, puts that information back on the data bus or backplane, and other modules consume that data. We will recommend that you have 2 PPMs or protection processing modules in every rack. That's mainly due to redundancy, but to align with SIL or API requirements, actually only 1 processing module would be required to align with those, but our recommendation is 2 for that redundancy standpoint. We'll also have a separate module for condition monitoring, and this is your gateway into System 1. You see here several variations of different input modules, whether it's a temperature or vibration. You also have relay outputs. We'll have both electromechanical relays and solid state relays. So you have options of a new option from a relay output standpoint. Solid state relays we see as being the #1 way to interface with the control system, and we see a much more lower use case on the electromechanical relays moving forward based on system design. And as I mentioned on the previous slide, we still have all the LEDs that are associated with all the different channels on the back side of the rack as well. So one key difference is there is individual channel level LEDs that are going to be multi-color LEDs, and it'll give you an indication of okay, bypass, alarm. Also some sensor health capabilities will be built into those as well. And as we release Orbit 60, we will be developing a separate configuration software utility. In this case, it's the Orbit Studio software, and it's a much more modern software suite. If you have any experience with like the ADAPT system that we've came out with, it's going to align a bit more towards that software interface. Or if you've had experience with System 1 Evo, you'll see a lot of similarities in the way this software is designed. So like dragging and dropping, cutting and pasting, those type of things will all be capabilities built into this system. As you can see, the visual relay logic there in the bottom left-hand corner is really neat. You can actually build your relay logic through some capabilities built into the software rather than long Boolean logic strings. We'll be able to do key phaser diagnostics. This is something that internally our own services team has been requesting, but many customers globally would like to be able to do diagnostics of the key phaser, which was a limitation previously. Multi-channel loop checks, so in the bottom right-hand corner. Traditionally, previous softwares of this like this, you did one channel of verification at a time. This software, you'd be able to bring in all your channels in one screen, so a much more effective way to either correlate information or to do loop checks in a much more effective and efficient manner. Multi-system connection. So the idea is here I could take multiple Orbit 60 racks and connect them to one instance of the Orbit configuration software. So I could copy and paste between systems. I can bring them all up at the same time to do maybe a global firmware update, global configurations. Orbit 60 software will be available in the offline mode as well. So you could work on something offline and bring it back online and upload accordingly. Improved security features, so we'll be able to have login credentials, so not anybody can just walk up to one of these Orbit 60 racks and make configuration changes. There will be things that you can set within the software to define who has access to, for example, a read-only version or a full configuration profile within that software. And then System 1 specifically, there's many advantages that come out of System 1 just inherently by developing a much more powerful and robust platform like this. One of them is deployment flexibility, so our ability to tie into a cloud environment. Now, Bentley just announced a new service as I'm talking here around Bentley Host, so we could store and host all the vibration data for our customers globally now through a software and services offering. What Orbit 60 allows us to do is a much easier means to connect to your fleet. As you can imagine, getting that data out into a hosted environment, that's where all the cybersecurity concerns currently are at. With Orbit 60 having that cybersecurity built into it, we're able to work with the IT folks to have that cloud connection at a much more efficient and reduced cost form. We're also finding that we're connecting into these Orbit 60s through cellular networks in some cases to get the data out if they're in a very remote location. So there's a lot of different ways to deploy it moving forward that we haven't had in the past. The System 1 embedded at a hardware. I mentioned this platform is 100 times the processing power of anything out there today. And what that really correlates to, it's a very fast and modern computer that's built into the Orbit 60. We have the ability to install a version of Orbit 60 at the hardware level. We're got to do some more evaluation of that to understand all the dynamics of that, but architecturally, that is something that we're going to be looking at in the future as a deployment methodology. A large data buffer. I don't know if I mentioned it earlier, but the Orbit 60 has a solid state hard drive built into it. Where 3500 had a data buffer, which, event came in, it would store the data during, while, and then after the event, send all that data over to system one. But as the next event come in, it would delete the previous event's data. Whereas Orbit 60, we have a very large solid state hard drive to capture multi-events over, let's just say, for example, 7 days of multi-event data on your particular asset. So if you have if your system one connection's down or you don't have a system one connection, you'll have some valuable diagnostic data that's stored on the system. The best-in-class roller element diagnostics, 3,200 lines of resolution in the first release, and then it's going to be configurable after. So really any type of asset around your facility. Process-driven data transient data capture. This is that process data coming in to trigger when you want to capture high-speed process data or high-speed transient data on your machines. Aldrich level capabilities. So what you see here in the Orbit 60 platform is the next generation of the Aldrich platform as well. It'll be repackaged in a more of a portable form, but the capabilities, the speed, the architecture, and everything else are what you see in the current architecture of Orbit 60. So it's very exciting as you see the vision of the next generation, portable analyzer tool equivalent to the Aldrich. The sandbox environment. So we want to take the CMM module and allow customers to install third-party apps to it. For example, if you want to take some of that data coming into the system, whether it's that process data or the vibration data, and you want to use MATLAB, for example, to do your own algorithms or analytics, you'll be able to do that here in the future based on the way this system has been architected. Multiple system one connections. So for example, if you want to send data to multiple places, meaning Bentley, Nevada has a remote hosted contract with your asset, but you also want to have local teams to have a view of the data. Maybe there's even an OEM that wants to view the data. You could put up to 3 different condition monitoring modules in an Orbit 60 rack and send them to 3 different locations, all with independent configurations, all completely isolated from each other as far as the type of data and the configuration. High-speed process data. I know I've said this many times, but it's one key difference in the architecture of Orbit 60. So this is one very exciting one for us because absolutely we're getting many more requests every day to have an easier means to connect all that data together rather than having multiple systems customers have to look at to correlate data. And it's also going to be a much faster data stream. As you can imagine, bringing that data in at the hardware level, you're going to get sub-1 second process data. Today, you would use an OPC client to bring it up and bring it into system one. You may have seconds of delay or even sometimes minutes of delay in that data. And so you have 2 different types of speeds of data between your vibration and your process data. And that'll become much more aligned here moving forward. And then, obviously align with the latest System 1 features. System 1 has 2 major releases every year. Decision support just came out in the latest System 1 platform. We talked about the diagnostic HMI to look at the whole process around you and your assets, and best-in-class visualization of your assets as well. So System 1 has a long roadmap of many new features and capabilities, and those all get unlocked as you tie these systems together. So I want to say thank you for taking some time out of your day to participate in the Orbit 60 discussion. It's been my pleasure to go through this with you. This is a new product, so I know a lot of people have questions on whether it's features or the commercial aspects of the system. Please reach out. We're very anxious to talk to our customers and to have these discussions with you on this new platform. So again, appreciate the time today, and thanks again for participating.